Hello, welcome to Anybody Can Learn. Today we will continue to learn perceptron. So let us understand what exactly is a mistake. The expression y times w transpose x plus b is the sign score. It is also called as a functional margin. Let's understand this very carefully. If y times w transpose x plus b is greater than 0, we will classify the prediction as a correct, and if y times w transpose x plus b is less than or equal to 0, we will consider the perceptron classification as incorrect. Now understand what do you means by the bias. The bias can also called as an intercept, and the basic equation is z is equal to w transpose x plus b, where this b means a bias and w means a weight vector and x is a feature vector and z is called as a score. The decision boundary lies exactly at wx plus b is equal to 0. So the wx is equal to minus b. So the x is equal to minus b by w. So bias allows the boundary to move away from the 0. Weight means the direction and bias shift the boundary away from the 0. Now consider the example of the ruler. The angle of the ruler determines the orientation. That means it is a W, and the placement of the ruler determines the position. So that means it is a B. So bias means a position or a shift, and a W or weight means orientation. Now calculate the weight vector. The weight vector's length is calculated by the formula Euclidean length formula. For a two-dimensional vector, x is a column vector with entry x1 and x2, then norm of x is equal to square root of x1 plus x2 square. Norm of x is equal to square root of x1 square plus x2 square. For 3 dimension, the length is norm of x is equal to square root of x1 square plus x2 square plus x3 square. Now understand what do you mean by the R. R means a maximum vector length among all the data points given to us, and it is calculated by the formula R is equal to maximum over I of the norm of the xi. That means we will calculate every data point length and take the largest among them. So the R means the length of the largest data points. Now consider the example. Suppose we have a few school bags and the weight of the school bag first is 5, the weight of the student 2 school bag is 8, and weight of the student 3 school bag is 3, and weight of the student 4 school bag is 10, and weight of the student 100 school bag is 7 kg. Now here R is equal to 10, that is the heaviest bag. So R means that data point that has the largest length. Why does the R matter? The perceptron updates the weight using the formula W new is equal to W old plus Yx. Here the size of the update depends on the size of the x. Since norm of xi is less than or equal to R for all the points, R gives an upper limit on individual update size. Now understand the margin, which is indicated by the symbol gamma. Margin tells us how well two classes can be separated. It represents the distance to the decision boundary. For the perceptron theorem, we assume a separating a vector exists. The margin must be strictly positive and therefore gamma should be greater than 0. The larger the margin means more comfortably the classes are separated. Now understand perceptron convergence theorem. If the training data point is linearly separable, then the perceptron will eventually find a separate hyperplane. In other words, if a straight line or a plane or a hyperplane can perfectly separate the two classes, then the perceptron will eventually stop making a mistake. If it can be perfectly separated, then it will eventually stop making a mistake. So this point to be remembered. The perceptron makes mistake bound. How many mistakes can it make? The maximum number of mistakes is bounded by the formula small t should be less than or equal to square of capital R divided by gamma. Equivalently, it can be written as small t is less than or equal to capital R square divided by gamma square, where t is the number of mistakes or update and R is the maximum data point length and gamma is the margin. What if the data is not linearly separable? The standard guaranteed assumption the data is linearly separable, but here is the difference between the linearly separable data and non-linearly separable data. In linearly separable data, the perceptron eventually finds a separating hyperplane, but in non-linearly separable data, the basic perceptron continues making a mistake and updates its weights indefinitely. But in linearly separable data, the algorithm converges and stops. So conclusion is convergence only happens when a separability holds. Now let's see some important formula. Score, that is Z, is calculated by the formula W transpose X plus B, where W is a weight vector, X is a feature vector and B is a bias. Prediction Y hat is equal to sine times W transpose X plus B, where sine of Z is equal to plus 1 if Z is greater than or equal to 0, or it is a minus 1 if Z is less than 0. Z means this W transpose X plus B. If W transpose X plus B is 0 or greater than 0, then we will predict the class as plus 1, and if W transpose X plus B is less than 0, then we will give minus sign, that is we will predict the class as minus 1. In the mistake condition is Y times W transpose X plus B is less than or equal to 0, and we will update the weight by the formula W new is equal to W old plus Y times X, as well as in the mistake condition we will update the bias by the formula B new is equal to B old plus Y. The R means a data point which has a maximum vector length. The perceptron norm bound gamma square times t square is less than or equal to square norm of Wt less than or equal to t times r square, and the mistake bound, that is small t, is calculated by the formula small t is less than or equal to capital R square divided by gamma square. It can also be calculated by the formula T is less than or equal to square of capital R divided by gamma. Thank you.